So on my side, my name is RogerAssaker. I'm the co-founder and CEO of MDsim. My background is in aerospace engineering, then did a PhD in computer modeling and simulation. Created the first company 20 years ago that I exited to the US, to the pioneer of computer modeling and simulation before running this company, which is several hundred millions in revenues and 2,000 people. And 3 years ago, I decided to leave this position to create MDsim, and I will tell you more about MDsim as we go. Go for it, Julia. Yeah,
Please do.
So the company name, first of all, thanks for everyone for taking the afternoon to join us for this 1 hour discussion about MDsim. So the company name is MDsim, and it's a play of word with medicine, basically, and it's simulation for the medical doctor. And what we are after is improve spine care, and improving spine care with technologies that we know, which is AI, combined to the concept of biomechanical digital twin. The first question is why you care, why you should care. And why you should care, because back problems basically concern each one of us. If it's not now, the bad news is that it will happen at some point of time. So 60 to 80% of people will experience serious back pain at some point of their life. So if it's not you, it's probably your parents or your children or your cousins or whatever. So, but basically, back pain concerns everyone. And as I'm speaking, I'm having some back pain problem, just to be honest with you. So back pain, it's okay. Most of the time will resolve in one way or another, but with aging population, will be more than 2 billion people above the age of 60 in 2050. So aging, we are living more and more. And also some diseases like scoliosis, osteoporosis, trauma, tumor will cause the spine to degenerate. So it kind of age and degenerate. And in some cases also will deform so that it will lose equilibrium. Today, spine care is doing a lot. We have a lot of very good spine doctors and spine surgeons, but I think that there are still more room for improvement, because today we treat the problem when it appears. So sometimes it's a bit too late because prevention is limited. Conservative treatment before going to surgery, basically one will go to a physiotherapist, will take some pain medication and so on. Sometimes it works, but it's not always good. And when it comes to surgery, it's pretty complex. And the typical surgery is, and I'm showing here a simple case, not like a case which will make you afraid, but it's a very simple case. But the typical surgery is to fuse the spine, to prevent the spine from moving and compressing some nerves or compressing other stuff. So, but basically what we call fusion surgery. And in simple word, you cut some vertebrae, you put screws and others, you put cages in between, and you connect them through rods. And then the spine will fuse together. It can be simple, like one segment, 2 vertebra fusion, but it can be pretty complex with, going from the pelvis to the head sometimes. And this surgery is complex, can take up to 10 hours. It's costly. In the US, a complex surgery can be $200,000 to $225,000. And the big problem with this surgery, it's so difficult that you cannot predict what will happen. And many times, up to 35%, 40% of the time, it needs revision. We will break something. You will break, for instance, in this case, we are breaking the screw, and it needs to be revised and resurgery. So this is the reason why we decided to build SpineSim, to develop SpineSim. SpineSim is our platform. It's a software, but it's a software as a medical device. As any other devices, is like a prosthesis, basically. It's a software. And the idea of the software is very simple, is to build a digital copy of you and me, a digital copy of the person, which is including all its biomechanics. So it builds a digital twin of the person. And the idea is the spine care professional will use this digital twin to improve surgery. So without getting too much into the details, but basically the starting point is the data that we collect, who you are, copies of your morphology, your digital images, your activity level, your pain level, the pain location. It's all a data. Today we are in a world of data. All this data we agglomerate it together into what we call a dashboard. And this dashboard will transform it into something actionable. We'll create out of the person, we'll create a digital twin, like you see it here as an avatar in blue, basically. And the focus is on the spine. We focus on modeling the spine with the bones, with the intervertebral disc, with the ligaments, with the muscles, and so on. And why it's important? Because with this digital twin, the surgeon can look at all the modalities, can look at CT, MRI, LiDAR images, X-rays, and so on. It can compute some data on it, like the gravity line, the degeneration of the discs, the quality of the muscles, and so on. And then at this point, he can say two things. Or you need some conservative treatment, and he will tell you, for instance, let's take one example, which is a morphology. Let somebody is overweight. He can tell you, you need to lose 10 kilograms and lose some belly fat, and you change your center of gravity and the load on your spine. So you simulate the effect of conservative treatment to help you improve without surgery. But if surgery is needed, the software will help you to plan the optimal surgery, a surgery which will balance the load on your spine, on your devices, to avoid revision. So SpineSim, it's a software as a service, like any technology, basically like any software that you are using today, like Microsoft, which is available on the cloud. And it has several modules, which are all used for different things. So the check, a module is to allow you to do a checkup center of your back to avoid surgery, to go to prevention. If surgery is needed, Align will allow the surgeon to plan how to go from a deformed spine, which is here in red, to a aligned spine, which is in green. Balance, it will allow you to compute the load distribution of your spine. Connect, it connects the patient to the application. And then we have a tool for B2B, for a medical device company to design patient-specific devices, and one for education to help senior surgeon educate junior surgeon. Why we should care? Because the objective of all this is, of course, to improve patient outcome, so to improve the life of the patient, to save money, reducing the time in the operation room, reducing the devices that are needed will save time, and save money, and save time for the surgeon to be more efficient. So why we created this and what is our added value to create this is the concept of digital twin. And I published a paper on it like earlier this week. The concept of digital twins that we are talking about today as a hot topic, new topic in medicine. I was leading the company that created this concept 60 years ago as a spin-off from NASA, basically. NASA, when they were trying to take Apollo to the moon, they used to build the launcher, to build the rocket on the launcher and vibrate it physically. And they tried to find a computer model which allows them to vibrate, to create a digital twin of the rocket and to vibrate it on a computer. So today in industries like aerospace, automotive, electronics, and so on, digital twin of the part which is used to design the part is standard. In medicine, it's less so. So I spent my career, 25 years, doing numerical modeling in industry. And the images that you see here was done by the companies that I was leading 3 years ago. And my brother, which is here on the right, is a professor of neurosurgery. He's been doing 15,000 spine surgery operation, 40 patents. And when we spent time together, he explained what I was just explaining to you. And I saw, why don't we take a technology, which is typically done by engineers on aircrafts and cars, and do it for the human body. And with AI today, it's possible to do it in an efficient way for a surgeon to use, not for an engineer. What you are seeing on the left, it's typically PhD in engineering who are using it. And what we are doing on the right is used by a surgeon. And the end result is a model of the spine. This spine is my own spine. So this is Roger's spine, which is modeled with what you are seeing in red and green are like the stresses in it. And one of my engineer, what he does is operated me actually. He said, you know, Roger on the left here, are you seeing my pointer? Let me just put the pointer. So here is my lumbar spine as it is moving today. Let's say I have a problem in L5, L4, and I need to fix the movement of this. Basically, I put screws in L5, L4, L3, and I connect them to the rod. So you see that in this disc and this disc, there's no movement. So the surgeon typically will need to say, should I fix him until here, or should I fix him until the pelvis? And with our tool, he can do the simulation, L3, L5, or L3, S1, and see what is the stresses on the bones and what are the stresses in the construction to be able to optimize it. So these are the three co-founders. What you have here is on the left is Richard, professor of neurosurgery today. On the right is Danny, who is a PhD in computer modeling and expert in quality and regulation. And I'm here in the middle. It's not the vintage. It's really, maybe it's our first picture altogether. So I already explained who is Richard, you know, a key opinion leader, one of, you know, the top surgeon in the world. Danny is leading our quality and regulatory. And myself, I'm an entrepreneur basically, and I have several investments in Medtech, LM in Barcelona, Twinside in Grenoble, and other technologies. I will not get too much into the details. We built a team. This is already, it's a 2 months old picture, but it's already old because we added 2 persons since then. You know, they started last week, so we are 2 more. And we have 4 interns working in engineering. And the 4th person, which is a quasi-founder, which is here on the right, is Laurent. He's been working with me in my first company since 20 years. We surrounded ourselves by a scientific board with professors from Germany, Switzerland, Luxembourg, and Canada, which are all specialized in spine biomechanics. And with a medical board on top of Richard, who is the chief medical officer, we have professor of orthopedic and neurosurgery from France, Paris, Bordeaux, from Japan, and from the US. They are all our key opinion leaders, which help us design the software. So in terms of business, the addressable market, you know, we are in the orthopedic, so it's a huge market, but the bottom-up computed market is 3 billion a year. So if we take our technology and we apply it on all the 2 million surgery which are done yearly, it's about 3 billion a year. So it's pretty big as a addressable market. We are aiming at using SpineSim on 25,000 patients by the end of 2028. Today, the software is not released. It will be released by the end of this year. So we are finalizing the software development and submitting it for FDA with the objective to start generating revenues in early 2026. So we are already pre-revenue, but we are already finalizing the software, the first version of the software, and we are already talking to FDA and to CE to get FDA clearance and CE marking. And the objective is to get FDA before the end of 25 to start selling early 26. And then we'll grow to 500,000 monthly recurring revenue by the end of 2028, which is around 5 million in annual revenue by the end of 2028. So in terms of funding, we created the company with the founder's money, 420,000. We added the pre-seed from 6 business angels of 1 million in 2023. We got the support of the Luxembourg government with non-dilutive funds of about 2 million. 1.6 plus 150 plus 50 plus 100 plus 150. So we have about 2 million of non-dilutive. And we closed our seed round of 2 million by the end of 2024. And the objective of this is to help us fund 25 and 26 to finalize the product and to take it to market and to start selling, basically to get to around 1 million in the end of 26. And we are planning a Series A in early 27, which will be combining an equity of 5 to 10 million plus non-dilutive of around 4 million from Luxembourg and from Europe. So we'll be 8.5 plus 6, we will be funding the company in total about 15 million. So why capital cell and why we opened the funding to you, and we hope to get you on board, is because I knew capital cells through my investment with LM. I liked a lot the concept of the bio expert network, so involving people which has life science experience. So they evaluated our project and they gave very good feedback. I liked the team, and during our seed investments, our ticket size was 250,000, so minimum 250,000. And we had a lot of people which are concerned by back problem, either as a surgeon or as a caregiver or as a patient or somebody interested by the topic in whole. They wanted to invest with us, but we could not accommodate small investments and to be able to manage them on the cap table. And so I think the fit is a win-win for all with Capital Cell. And why you should invest through Capital Cell? Basically because I'm sure that you are concerned by back problems, if not you directly, through somebody that you know and you care about. It's an extremely interesting technology with digital twin, AI, computer modeling, cloud, and SaaS. So the technology is brilliant behind it. And it's also not this, it's also win-win for everybody. Win for the patient, better outcome. Win for the insurance and social security with reduction of cost. A win for a surgeon because he will be more effective and more efficient. And the win for you as an investor, because I cannot guarantee it 100%, but I bet we will have a good financial return on the investment. So the time is now, and we are ticking all the boxes of what's going on in healthcare. Personalized medicine, affordable medicine, digitization, AI, and you name it. And all this coming together at the right time to invest in MedTsim. And I'll be happy to answer any questions that you may have. Thank you so much. And on the right, it's again me with the team playing with my X-ray to make me bow and say thank you. So thank you for your attention.